My name is Miss Connolly. I started making some videos for my 5th graders and decided to make them public for everyone to learn during this crazy time. My hope is that I can use it for homework help for the rest of my teaching career. So let's get started. If you have any topics you want me to cover, connollymathathome@gmail.com. I teach 5th grade, but I can do other math, 5th grade or under. So don't ask me for middle school stuff, sorry. But let's get started with what we're going to do today. I just posted a video on US standard measurement conversions, and today I'm going to be talking about metric units. So if you look at our poster over here, sorry, I don't have any chart paper markers, so it's with a Sharpie, so I hope you can see okay. So measurement equivalents with metric units. In the United States, we use US standard units, but other places in the world are using metric units. So let's take a look at how they measure things other places. So we have 1 centimeter, which is a teeny tiny little thing. Okay, probably smaller than what I'm even showing. Maybe the length from one side of my pinky to another. Inside one of those tiny little centimeters is 10 millimeters. So if you look at the centimeter side of the ruler, and sorry, at home, I didn't bring home any rulers, but you'll see these teeny tiny little dashes, and there's 10 between each centimeter. Those are all millimeters. They're very tiny, like the width of your finger, like the actual fingernail or the tip of a pencil. Okay, so that's what we have with the millimeters there. 1 centimeter equals 10 of those. When we're thinking about meters, meters is almost the same length as a yard. So we went over yards in US standard measurement, about here, 3 feet, but 1 meter is the same as 100 centimeters. So you notice that instead of the weird equivalencies we saw with US standard measurements, these are all multiples of 10 and multiples of 100 and 1,000. So I think metric units are a little easier to convert. So 1 meter is the same as 100 centimeters. And then for kilometers, so in the United States we talk about miles. Kilometers is something comparable to how we measure in miles. So 1 kilometer is 1,000 meters. So in Canada, for example, you will see kilometers per hour instead of miles per hour, and that's what they're saying. That's how fast you're allowed to drive, is how many kilometers per hour. So those are all length measurements, and I have the abbreviations over there. Take a screenshot, write these down so you have it as a reference sheet while you're doing your work. For mass, we're talking about how much something weighs. So the conversion you need to know for that in 5th grade is that 1 kilogram is the same as 1,000 grams. Okay, so 1 kilogram the same as 1,000 grams. And then with capacity, how much you can fit inside a container. When we think about 1 liter, that is the same as 1,000 milliliters. So for reference, this is a 1 liter size bottle of water. Usually the ones you see, the smaller ones are half of a liter. So this is 1 liter inside here. The same measurement would be 1,000 milliliters. Okay, so let's get started on some conversions. So you might be asked a question like this. If you have 6 meters, how many centimeters do you have? So in the last video, we went over some input-output tables so that we could make sense of what's going on. So if we have meters on one side of our table and centimeters on the other side, I know that if I have 1 meter, I have 100 centimeters. I know if I have 2 meters, I have 200 centimeters, 3 meters, 300 centimeters. And then in that video, we talked about if you had any number, n represents any number of meters, what would you do to it? Any number of meters. So if you look at what do you do to the 1 to get to 100, what do you do to the 2 to get to 200, what do you do to the 3 to get to 300? We're thinking about what do you do every single time to get from meters to centimeters. And pause if you need a second to think. Each time you're thinking about multiplying the number of meters times 100, and that gets you the number of centimeters. So once you come up with a rule, and some of you can see the rule here, you don't have to do the input-output table, but it's helpful to develop the rules for what's happening in this table so you can solve for any number. So what we're going to do is we're going to think about, we have 6 meters, We're going to multiply by 100 because every meter is a group of 100 centimeters. So if I have 6 groups of 100 centimeters, I have 600 centimeters. Okay, so that's one example. If I'm thinking about going from kilometers to meters, I am thinking about what's the rule each time. So if I have 1 kilometer, I have 1,000 meters. So if I have 6 kilometers, I have 6 groups of 1,000 meters. So that's 6,000 meters. Okay, so when you're thinking about going from the measurement that's longer, the meter, and trying to figure out how many of the smaller units fit inside, you're going to need more of them to make the same amount. So we're multiplying when we go that way. Okay, again, make sense of it in the input-output table. It's really important that you have a good hold on what's going on each time. So something else that you're going to see when you're working on your conversions with metric units is you're going to see things like what happens if I have 6 and 5/10 of a meter. So 6.5 meters. We developed a rule here that every single time that I have any number that I have in meters, I'm going to multiply by 100. So this is when I love math, and I know I'm such a dork, but all the things that you've learned are coming together. So you've learned about multiplying decimals, so let's think about it. 6 and 5/10 times 100. We know that every time that we multiply by a multiple of 10, well, let's start with 10. So each time we multiply a number by 10, the digits all get 10 times greater. Okay? So when you're multiplying 6 and 5/10 times 10, we have a 5 in the 10ths place. If my 5 is going to get 10 times greater, then it's going to shift over to the ones place. Then, when I multiply 6 times 10, the 6 that's in the ones place then shifts to the tens place. So each digit got 10 times greater. So 5/10 times 10 is 50/10, which is 5 wholes. 6 times 10 is 60, which we put the digit 6 in the tens place. So each digit shifted over 1 time to the left because each digit is getting 10 times greater. So what happens when we multiply by 100? Each digit is going to get 100 times greater. So the digits are going to shift the 2 place values to the left. So it's going to go 10 times greater, 100 times greater. And I can think about it as 100 groups of 5/10 is 500/10, which is the same as 50. Okay, so 500/10 is the same amount as the number 50. And then 6 times 100 is the same amount as 600. So the 5 used to be in the 10ths place. When I multiplied by 10, each digit got 10 times greater. It moved over 1 place value. When I multiplied by 100, each digit is getting 100 times greater. So it moved 2 place values when I multiplied by 100. So that's just something to think about. You've learned about what's happening when you multiply a number by a multiple of 10, a multiple of 100, a multiple of 1,000. The digits are shifting to the left. Every time it shifts 1 place value, it's getting 10 times greater. So if you wanted to get 100 times greater, it shifts 2 place values. So something you're going to have to think about is making that connection between what you learned about multiplying decimals, and you're going to have to bring in your knowledge of what's happening when you're converting from meters to centimeters and bring them all together, and that's why math is so fun. So 6.5 meters is the same as 650 centimeters. So when you're doing conversions, you're going to see questions like this where you have, you're not going to have a whole number over here. You're going to have between holes, and you're going to have to figure out, how do I multiply by 100? How do I multiply by 10? How do I multiply by 1,000 with those decimals? So metric units, we're working on conversions, but we're also working on multiplying decimals by a multiple of 10, by 10, 100, or 1,000. Okay, so let's think about some other situations you're gonna see when we're using metric units. So let's say that let's say I have 500 grams and I want to know how many kilograms is that. So I have 500 grams, how many kilograms is that? Okay, some of you might already be seeing it and that's great, but I want to make sure that we connect everything. So let's talk about grams to kilograms in an input-output table. I know that if I have 1,000 grams, I have 1 kilogram. I know that if I have 2,000 grams, I have 2 kilograms. And if I have 3,000 grams, I have 3 kilograms. So what you want to ask yourself is, what do we do every single time to figure out how to get from 1,000 grams to kilograms? How did I get from 1,000 grams to 1 kilogram? I do the same thing to get from 2,000 grams to 2 kilograms, 3,000 grams to 3 kilograms. I want to know if any number at all was in here. Any number at all? What would we do to it to figure out the number of kilograms? So pause if you need a second to see the relationship between the rows. And if you're back, n divided by 1,000. So if we divide any number by 1,000, we're going to end up with the number of kilograms, which is fun and exciting because now we have to divide 500 by 1,000, a whole number, divided by a whole number. One of my favorite things to do. So we determined that for any number of grams, to get the number of kilograms, we would divide by 1,000. So here we are with 500 divided by 1,000. And we know that you cannot make one full group of 1,000. So we have to bring in stuff that we've already learned this year. Okay? So I'm going to run out of space, so I have to erase this. Sorry. One of my favorite understandings for all of you, the entire school year, is when we finally get it that the fraction bar represents division. Okay, so 500 divided by 1,000, another way we can write that is 500 divided by, because that's what the fraction bar stands for. It's so exciting. 500 divided by 1,000. So that's another way. This is equivalent expressions here. 500 divided by 1,000 is the same as 500 divided by 1,000, which is the same as 500 thousandths. And now we bring in even another thing that you've learned. You know how to write 500 thousandths as a decimal. So we're going to write 500 thousandths. And that is 500 grams is equivalent to 500 thousandths of a kilogram. Or another connection is, you know that this is equivalent to a half. So you can write it like this. You can write 5/10 of a kilogram. You could write 50 hundredths. You could write 500 thousandths. Or you can say that 500 grams is equivalent to half of a kilogram. Okay, so let's try another one. We'll do 2 more, so we make sure we cover all the different ones. So we did a mass one. Let's talk about liters. So let's say that you have 7 2/10 liters, and I want to know how many milliliters is that. So when you look at the conversion, if I'm going from liters to milliliters, am I going to have more milliliters? Will the number be greater? Or am I going to have less milliliters? When we think about it, 1 liter times 1,000 is 1,000 milliliters. So I know that since this is a smaller measurement, that I'm going to be multiplying to figure out how many milliliters I have. If your understanding is not there yet, then you just go ahead and make the input-output table. You think about what's going on as you add a liter. You add 1,000 milliliters. Add a liter. Add 1,000 milliliters, and then You get to the understanding, what am I doing each time to figure out the number of milliliters, and you'll see that you're multiplying by 1,000. Okay, so rely on anything that you have to get to the understanding and figuring out how to solve. So, again, love multiplying by decimals. So let's do it. So we have 7 and 2/10 times 1,000. So if we wanted to, we could multiply in parts. So I could say 7 times 1,000 is 7,000. 2/10 times 1,000 would be 2,010ths, which is the number 200. And I could say I have 7,200 milliliters. So you can multiply in parts, or you can think about what's happening with the size of the digits every time that we multiply by a power of 10. So we have a power of 10 here. 10 to the third power is 1,000. So when I'm multiplying any number by 1,000, each digit is going to get 1,000 times greater. Okay? So 7 is currently in the ones place. I want to show that it's getting 1,000 times greater. So when I think about how many place values it has to shift over, it's going to go from the ones place to the tens place. It gets 10 times greater. Then this is 100 times greater, 1,000 times greater. So it shifted one time for 10 times greater, 2 times to the left for 100 times greater, and 3 times to the left for 1,000 times greater. So there's a relationship here between where the digits are in your powers of 10. 10 to the third power is 1,000, and it shifted 3 times to the left. 10 to the third, 3 times to the left. Interesting. Okay? So when I think about 7 and 2/10, I'm going to shift the 2 now 3 times to the left. So if it got 10 times greater, it would shift 1 time to the left and go, because 10 groups of 2/10 is the number 2, 20 tenths. Then if I'm shifting, and this is becoming 100 times greater, it would shift to the ones place and then to the tens place. And then if it was getting 1,000 times greater, it shifts 3 place values. It gets 10 times greater, 100 times greater, 1,000 times greater. Okay, so there's a lot of understanding going on when we're using metric conversions. When we're multiplying by a power of 10, we're thinking about how many digits, how many place values the digit shifts. Okay, so we have 7,200 milliliters is equivalent to 7 and 2/10 liters. All right, let's do one more where we're dividing by a power of 10 so that we can see the digit shift the other way. All right, last one, and then you're going to try some on your own. I'm sure whichever teacher is assigning you this stuff has some worksheets for you. Use the conversion, the input-output table, decide what's going on, and then make sense of your multiplication equation. So let's say that we have, I want to divide, so I'm going to say that I have 650 centimeters, and I want to know how many meters is that. So first I'm going to say what happens going centimeters to meters. If I have 100 centimeters, I have 1 meter. If I have 200, if I add another 200 centimeters, that's 2. If I add another 300 centimeters, that's 3. And then you try to figure out what's going on. How do I figure out how many meters I have if I have 100 centimeters? What do I do to this number to get here? What do I do to this number to get here? It's going to be the same thing every time. And what do I do to 300 to get to 3? So the rule, I'm sure that you're discovering, is n, any number, gets divided by 100, and that's how we figure out how many meters we have. So let's look at this a couple different ways. We have 650 centimeters. I need to divide it by 100 because I decided that's how I'm going to get from the number of centimeters to the number of meters. So I divide by 100. And a couple things can happen right now. We know that the fraction bar represents division, so we have 650 divided by 100, which you know is an improper fraction. So how many whole groups of 100 fit in 650? 6. Okay, so I've taken out 600 hundredths, and I have 50 hundredths left. There's a video on changing improper fractions to mixed numbers, so check that out. So I know that 650 centimeters is the same as 6 and 50 hundredths, which can be written like this, or like that. Okay, so 6.5 meters. But let's think about what's happening with the digits here, okay? So we have 650, and we are dividing by 100, so each digit needs to get 100 times smaller. So let's look at if we divide by 10. If we divide by 10, the digits are now shifting the other direction because they're getting smaller. So 650 divided by 10, if the 6 gets 10 times smaller, 600 divided by 10 is 60. Then, so we're in the tens place, and 50 divided by 10 is 5. So do you see how the digits are shifting when you're dividing by 10? One time. If I divide by 100, let's see what happens. So I'm going to divide 600 by 100. My digit 6 is shifting 2 place values over to the ones place. And 50 divided by 100 is 50 hundredths. So it's shifting to the tenths place. So when I divide by 10, it shifts 1 place value. If I divide by 100, it shifts to the tens place, to the ones place. Ready? Shifts 10 times smaller, 100 times smaller. You want to go 1,000 times smaller? Go 1,000 times smaller. It's going to shift over again. So that's 650 divided by 1,000, which you all know matches up there. Okay, so while you're working on conversions, you are using an input-output table to determine what the rule is in order to get from one measurement to equivalent measurements. The other thing that's happening is when you're multiplying and dividing by a power of 10, you're thinking about how much bigger or smaller those digits are getting when we multiply or divide. Okay, any questions? ConnollyMathAtHome@gmail.com. Make sure you take a picture of this so you can refer to it, and I hope it helps.